few more. Today we'll talk about the structure of the bone, ossification of the bone. Ossification is the process of formation of bone. You know that in fetal skeleton, whole skeleton is what? Hyaline cartilage. Remember that? In fetus. Then from the hyaline cartilage, the bones are formed. So that process, how the bones are formed, is called ossification or osteogenesis. Same thing. Formation of bone. There are two ways ossification occurs, or bone formation occurs. One is called interchondral ossification and another is called intramembranous ossification. So, in those two ways, the bones are formed in the body. So, we'll talk about both. Then we'll see the blood supply of a long bone. Hormones work on the bones and the hormones work to regulate the calcium in the blood. So two types of hormones are there. One type of hormones work on the bones to grow the bones. Make sense? And another type of hormones work on the bones to regulate the calcium in your blood. So we'll talk about both types of hormones. So first, you see the structure of a compact bone. You have already seen under the microscope. You must remember when you saw the bone tissue under the microscope, you saw many round structures. This pen is not working. Many round structures like this. Okay, and each round structure is called an osteon. So many osteons are there in the compact bone, and in the center of the osteon there is a canal, right? That is called the central canal. You have seen this. Inside the canal, you have blood vessels and nerves, because you know that bones are vascular. Bones have blood vessels and nerves, right? But cartilaginous ligaments, they don't have, right? So, you have artery, you have a vein and a nerve inside the central canal. So you have artery, vein and nerve. Okay, so those are the structures pass through the central canal. So artery, vein and what? Nerve. Okay, pass through the central canal. So each osteon has a central canal, and you have many tiny cavities. Those are called lacunae, small cavities called the lacunae, and inside the lacunae you have the mature bone cells, osteocytes. So you have osteocytes inside the lacunae. So this is the bone cell. So you can say osteocyte within the lacunae. Okay? So all these lacunae contain osteocyte, mature bone cells. Okay? And outside of the lacunae, you have the hard matrix of the bone. So bone matrix is very hard. That gives the hardness of the bone. You know, bone is very hard, right? So this matrix is called lamella. Hard matrix of the bone is called lamella. Okay? And this matrix has a lot of minerals. Which minerals? Anybody? Calcium and phosphorus, calcium phosphate. Lot of calcium and phosphate. Okay, so that is the matrix. One more thing you need to know, that the central canal is connected to the lacunae by very thin hair-like channels like this. And also one lacuna is attached to or connected to another by those fine channels, very thin hair-like channels. And through these channels, nutrition and oxygen from the blood goes to the lacunae. Since they are connected to each other, nutrition and oxygen rich fluid will go from one lacunae to another. Why? Because inside the lacunae you have what? The bone cells, right? Osteocytes. And they need continuous oxygen and nutrition, right? Otherwise they will die. So the fluid going to those lacunae, and that fluid contains nutrition and oxygen, right? To supply goes to the osteocytes. And these fine channels are called canaliculi. Okay, canaliculi. So this is the structure of a compact bone, and all osteons are same. Like all these structures are inside the osteons. And each osteon is the structural unit of the compact bone. So, structural unit of bone. Okay? Now, actually, if you see the structure of a compact bone, it is like this. Look at this. Bundle of columnar structures. Okay. Now if I make a cross section, cut like this and see under microscope, it will look like this, right? So many circles. That's what you see here. So each circle is like this, a column. Make sense? So many columns are bundled together to form the compact bone, and each column is the structural unit of this whole thing, right? That is the osteum. Okay. Now, that is the structure of the bone. So here you see one osteon, another, so many osteons are there in the compact bone. And spongy bone is different. It's incomplete. Osteons are there. You see the lacunae, cavities, and inside the lacunae you have the osteocytes. And lamella is the hard matrix of the bone. And this is the central canal that contains the blood vessels and the nerve. Okay. Spongy bone contains trabeculae processes. Now, if you see the chemical composition of the bone, bone has both organic and inorganic compounds. So bone is formed by both organic and inorganic compounds. The organic compound is called the osteoid. So osteoid is the organic compound or component of the bone. And the osteoid or organic part consists of collagen fibers. So collagen fibers and ground substance, which is the chemical ground substances. Okay. So these two things together form the osteoid, which is the organic part of the bone. Now, inorganic chemicals include calcium phosphate. You already know. Calcium phosphate. Okay. And about 60% of bone mass is given by the inorganic compound. Okay. And the calcium phosphate or inorganic compound gives the hardness of the bone that I mentioned. So hardness is mainly given by the inorganic part. And inorganic part is the mineral salt, right? Calcium phosphate. So mineral salt. Okay. Inorganic is mineral salt, which is the calcium phosphate. Organic is the osteoid, which consists of the collagen fibers and the ground substance. So this is the chemical composition of the bone. Okay, as both organic and inorganic. Okay, so next, osteogenesis or ossification. What is that? I mentioned already, the process of bone formation. So bone formation occurs in two ways. One is called intermembranous and another is called endochondral. So first, ossification or bone formation occurs in two ways. One is called endochondral and another is called intramembranous ossification, okay, or osteogenesis. Now endo means what? Inside. Very good, right? Intra means what? Inside. Same thing, right? Endo or intra. So sometimes we say endochondral, sometimes we say intrachondral. Same. Make sense? Chondral means cartilage. Chondro means what? Cartilage. So from inside the cartilage. Make sense? Endochondral means what? Inside the cartilage. And you already know that fetal skeleton is hyaline cartilage, right? And that hyaline cartilage is converted to bone, becomes bone. So most of the bones come from that hyaline cartilage. Okay? From hyaline cartilage of fetal skeleton. That makes sense, right? So that's why it is called endochondral. From inside the cartilage, bone is formed. Make sense? Few bones come from a membrane, and only few bones are formed by the membrane, and that is called intramembranous ossification. Okay, let's first talk about this, then talk about this. Okay, so which few bones come from membrane? Clavicle, the collarbone, this one, right? And most of the flat bones of your body are formed from membrane. Rest of the bones of the body are formed from cartilage, endochondral ossification. Okay? Except the clavicles and flat bones like sternum, parietal bone, right? Occipital, those are the flat bones. First, this is important. I may ask you to explain and draw the steps of endochondral ossification. How a bone is formed from cartilage. So let's first draw a cartilage. So this is a hyaline cartilage, okay? Hyaline cartilage. So bone will be formed from this. So first what happens? Osteoblasts are formed around the cartilage. So these are newly formed osteoblasts. So cartilaginous cells around the cartilage will be converted to osteoblasts. Okay, so some cells around the bone, around the shaft of the bone, will be converted to osteoblasts. Osteoblasts are what kind of cells? We talked about that in last class.
We destroy or
Young cells, right? Young cells. And they produce matrix. Remember that? Osteoclasts are destroyed. Okay. So osteoblasts are young cells, right? Young bone cells, and I told you that they produce matrix, right? So these osteoblasts will produce and secrete matrix around the shaft of the cartilage, and this will become hard matrix of bone around the shaft of the cartilage, and this is called bony collar. So osteoblasts will secrete matrix here, and that will form the bony collar around the shaft of the cartilage. So this is the collar. Okay. Then at the same time, another thing happens in the center of the shaft. Chondrocytes are the cells of the cartilage. Chondro means cartilage, cyte means cells. So these are chondrocytes. Okay? In the center of the shaft, these chondrocytes or cartilaginous cells will start to get bigger. That is called hypertrophy. hypertrophy of chondrocytes. That means these chondrocytes will get bigger, larger, and occupy more space. Make sense? If they get bigger, they will occupy more space here. And these chondrocytes will secrete an important chemical that is called alkaline phosphate. So two things will happen in the center. Number one, the chondrocytes will get what? Bigger, right? Hypertrophy, enlargement, and occupy more space. And number two, will secrete what? Alkaline phosphate. Okay? This alkaline phosphate does what? Calcium deposition to form new matrix. Calcium is the main component of the matrix. Okay? So, calcium deposition will occur. Okay? Here. Make sense? Okay. So, then what will happen? You see, very interesting. These chondrocytes will get bigger, 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 and at one point they will burst, rupture, and die. So they will do what? Rupture and die. Make sense? So a cavity will be formed here. Make sense? If the cells burst, right, then and die, a cavity will be formed in the center. And this is called what?
Osteogenesis.
Medullary. Have you heard medullary cavity? Remember that? Medullary cavity. So this is the medullary cavity inside the shaft. Make sense? Okay. Then what will happen next? Cartilage is avascular, right? No blood vessel. But bone has blood vessel. You know that, right? So when it was a cartilage, there was no blood vessel, right? But now, since it is becoming bone, the blood vessel must enter. Make sense? So next what will happen? A blood vessel will penetrate, will enter into the medullary cavity, into the bone, and will branch like this. So bone will get blood vessel. Okay, will enter. So let's quickly review before I move forward. Okay, so in early part of life, this is what this is a hyaline cartilage. Make sense? In a fetus, it will become a bone, right? So that is ossification, endochondral ossification. So first, around the shaft, what will happen? The osteoblasts will secrete matrix, right? And a bony collar will be formed. Make sense? And at the same time, so this is number one, collar will be formed. Number two, in the center of the shaft, chondrocytes will get what? Smaller or bigger? Bigger, enlarged, right? Hypertrophy, and will occupy more space, right? Hypertrophy of chondrocytes. And also they secrete what? Alkaline phosphate. That helps in calcium deposition. Make sense? So new matrix will be formed here. So that is number 2. Number 3, the cells will burst, die. So a cavity will be formed in the center of the shaft, right? And that is called the medullary cavity. Make sense? And number 4, blood vessel will enter into the medullary cavity. Make sense? And then what will happen next? 2 more in 2 more areas, the chondrocytes will form the centers. These are called secondary ossification center. This one, when the chondrocytes were formed, this area is called primary ossification center. Primary, where the chondrocytes enlarged. Primary ossification, okay, center. And these 2 will come later, and that's why they are called secondary ossification centers. So 2 secondary will appear at the ends of the cartilage and will start to form the matrix same way. Now the last thing you need to know is, you see the matrix is here and matrix is also here. That means the bone formation is occurring in this part and this part. And this part still is a cartilage. This is still a cartilage. No matrix is there yet. And this is called the growth plate. I believe many of you have heard. This is called growth plate, which is hyaline cartilage, right? Still there. So this is growth plate. This is also growth plate. And as more and more matrix is formed like this, the growth plate gets narrow and narrow, shrinks, right? And finally, a thin plate of hyaline cartilage remains here, and that is called the epiphyseal plate. So growth plate will become a thin plate and remains there throughout the life, rest of the life. This thin plate of cartilage will remain there. Also same thing here. The growth plate will shrink, will get narrow, and will stay here as a thin plate of cartilage. And this is called epiphyseal plate. So this is one epiphyseal plate, hyaline cartilage. This is another epiphyseal plate, hyaline cartilage. And it is always there in the long bone. Will never be converted to bone, this thin plate of cartilage. Make sense? That means what? This is a weak point in your bone, right? Fracture can easily occur here. Make sense? Because cartilage is softer than bone, right? You know that. So the head part can get, detached from the shaft. That is called epiphyseal fracture. If fracture occurs here, that is called what? Epiphyseal fracture. Make sense? And which occurs. Anyway, so this hyaline cartilage, thick hyaline cartilage is called what? Anybody? Thick hyaline cartilage is called what? Growth plate, right? And it gets narrow because bone formation is occurring from this side as well as from that side, right? So getting narrow, right? And finally, will stay as a thin plate of hyaline cartilage. Make sense? Which will never be converted to bone. Will stay there rest of your life. So that is called what? Epiphyseal plate. Make sense? Okay. By looking at the thickness, size of the growth plate, you can tell the exact age of a person. By looking at what? The growth plate. How thick? The size of the growth plate, you can determine the age of that growing person. Because this change occurs in very timely manner. So now, this is used in forensic medicine. Like, you have found a dead body, most part has been destroyed, right? You've got the bones, no other features are left, so you can measure the growth plate size, right? And tell the age of that person. Okay, makes sense? So, this is very time sensitive way it changes. So if I ask you, show me how endochondral ossification occurs, these are the changes you need to remember. Okay? I know you have understood, but you have to study to remember it. Okay? Remembering is important. Okay, so that is one way. Most of the bones are formed this way, right? But another way is from the membrane, intermembranous ossification. What happens in intermembranous ossification? The bone is formed in a membrane that is called mesenchymal membrane, formed by mesenchymal tissue, which is an embryonic tissue or embryonic membrane. Okay? So this is the mesenchymal membrane, and inside this membrane you have the cells, and these cells are called fibroblasts. I'm sure you have heard the name. These are fibroblasts. Okay, fibroblasts. Okay. So what happens? First, some fibroblasts in the center of the mesenchymal membrane are converted to osteoblasts. So these fibroblasts, those are in the center of the membrane, will be converted to osteoblasts. Okay? Osteoblasts are what? Young bone cells, right? And will produce matrix. Same thing, right? So let's see what happens here. These fibroblasts will become osteoblasts. So these are osteoblasts. Okay? And they will secrete matrix around them. Initially, this matrix is soft, like fluid, but gradually it becomes what? Hard, because you know that the matrix of the bone is very hard. That gives the hardness of the bone. So this matrix around the osteoblasts will become hard matrix. Called the lamella. Now you see what happens. the osteoblasts will get older, right? And I told you in last class, when you are young, you are healthy, right? When you get old, the size gets what? Smaller, right? Make sense? Remember that? In last class I showed you that osteoblasts are healthy and they produce matrix, right? And when they get old, the size is small, okay? So when these osteoblasts will get mature, they will get smaller. But the matrix is hard, remember already. So what will happen? Osteoblast will become osteocyte. So this is osteocyte. Osteoblast will get smaller and will become what? Osteocyte, mature cells, old cells. But the matrix is hard, right? So what will happen? The matrix around you is hard. Now you got smaller. So a space will be created. Matrix will not move, right? Because it is already like cement, hard cement. So cell is getting smaller, right? So a space will be created around the cell. Make sense? And that is what? The lacunae. You remember I told you the spaces inside which the osteocytes reside. So this is the space. This is the cell, this is the matrix, and this is the space, right? So this is the space. Same thing here. You see, matrix here, then the cell is here, and this is the space. So that's how lacunae. And inside the lacunae, you have osteocytes. Mature cells, right? Are trapped inside the lacunae, inside the cavity. So that's how the osteocytes within lacunae are formed and hard matrix is formed. Okay? So that's how the bone tissue or bone is formed by intermembranous ossification from the membranes. So these are the changes during bone formation. Okay? Okay, and only few bones, the clavicles and flat bones, come from that mesenchymal membrane. Blood supply of a long bone. If you see a long bone, 3 sets of blood vessels supply blood to a long bone. So this is a long bone. Okay. In the center of the shaft, if you see the femur or the long bone, you will see a tiny hole in the center middle of the shaft. That is called nutrient foramen. So you have a foramen here called nutrient foramen through which the blood vessels pass. So that is called nutrient artery and a vein, that is the nutrient vein. Okay? So that is nutrient artery and vein through the center of the shaft, through the nutrient foramen. So that is one set of blood vessel, and it supplies blood mostly in the shaft of the, inside the shaft of the long bone. Then there is another set of blood vessels. You remember the epiphyseal plate, the growth plate gets thin and thin plate. So this is the epiphyseal plate. So through that area, another set of blood vessel enter, artery and vein, and this set of artery and vein is called the metaphyseal blood vessels. So this is number 2, metaphyseal vessels. Okay, enters into the bone through the area where the epiphyseal plate is at both ends. Okay. So they supply blood mainly to the ends of the long bone. Makes sense. Then the covering of the bone. You know that the covering of the bone is called what? Anybody? Covering of the bone that protects the bone.
The membrane.
What is that? If you don't know, then you don't know the layers of it. It has two layers. Periosteum. You should know it by now. You are not starting from. In last class, I spent a lot of time. Periosteum has how many layers? Two, right? Outer fibers, inner osteogenic or cellular layer. You need to, keep studying. Don't wait until the exam comes. So periosteum is the covering of the bone, right? So if you see inside the periosteum, there are arteries like this. So this is called periosteal blood vessels. Periosteal vessels, number 3. Okay. So periosteal vessels supply blood to the periosteum, the covering, as well as very outer part of the shaft of the bone. Okay. But inner part of the shaft is by the nutrient artery. Make sense? So 3 types of blood vessels, right? One enters through the middle of the shaft, that is called what? Nutrient blood vessels, right? Supplies blood to the inner part of the shaft of the bone, right? And near the epiphyseal plates, the blood vessels enter or pass through. Those are called the metaphyseal blood vessels, mostly supply blood to the ends. And in the periosteum, the covering, you have the periosteal blood vessels. Make sense? Okay. So those are 3 sets of blood vessels, supply blood to the long bone. Here you see in the picture, okay? Nutrient, artery and vein, metaphyseal, and periosteal is in the periosteum here. Remodeling of the bone. Throughout the life, bone is being destroyed and bone is being produced. So bone tissue is being formed and bone tissue is being what? Destroyed. Both are happening simultaneously. Make sense? At the same time. All the time. Bone tissue is being formed, new bone tissue, and old bone tissue is being destroyed. And that is called remodeling. Okay? Now, you tell me, in early part of your life, when the body is growing, which one is more? Growth is more or distraction is more? Growth is more, right? That's how the bone is growing. So distraction is less, loss is less, right? And in the late part of your life, when you are old, production is less, right? And loss is more. That's why bones get what? Small and weak. Make sense? Very weak. Because the matrix is being destroyed but is not being replaced by new matrix. Make sense? So, remodeling occurs throughout the life. But in early part, formation is more, loss is less. In late part, loss is more, but replacement of formation is less, right? And that is remodeling. Bone remodeling also occurs when fracture occurs, right? If you get a fracture, new bone tissue is being formed, right? To heal it. And I told you, not only new bone tissue is formed, it's like a crack on the wall, right? you put the cement there, but later you do what? Polish it, right? So new bone tissue is formed, but excess bone tissue is removed from there, right? So you see production as well as distraction. So remodeling occurs during the healing of the fracture too, right? During the repair of the fracture. Okay, now the hormones. Two types of hormones I told you. One type of hormones help in the growth of the bone. Growth of the bone. The main one is called the growth hormone. Have you heard this name? Growth hormone? I believe all of you. So, growth hormone works on the bones to grow the bones. Stimulates the growth of the bone. So, this is one. Another hormone is thyroid. Thyroid hormone also helps